Hi everyone, thanks for joining today's session on Azure Data Fundamentals. And today we have Papula with us, who is a Microsoft certified trainer, and we will be taking us through the basics you need to be knowing to go for the Azure Data Fundamental exams and what does you need to be getting started on it. So without any more delay, let's get into it. And I'm moving the mic towards Papula. Over to you.
All right, thank you. Thank you for having me. Just a minute, let me share my slide. Trying to share my slide. All right, please confirm you can see my slide.
Yes. Yes.
All right, okay. All right, everybody, good morning, good afternoon, good evening, wherever you are joining us live. According to your time location, if it is the morning, good morning to you. If it is afternoon, good afternoon to you. And if it is evening, good evening to you. Um, my name is Popola Iseka. I will be your trainee instructor for this particular session, which is on data Azure Data Fundamentals. That has an acronym, or that has a name as DPN 100. Before we start, let me take us through the presentation outline. We'll be looking at the more about your instructor. We'll be looking at the modules, and we'll also be looking at study materials. So this is the lineup of what we have for today. As regard to your instructor, Kupola is my surname. Isaka Olamineka is my name. I am information technology specialist with more than 10 years work experience. I have specialty on business intelligence and data analytics. I do consultancy services for corporate organizations in terms of technical training. I also do consultancy services in terms of providing solutions to business issues. I do public speaking and also take part in community development across the world, not only where I am based. I'm based in Nigeria, but I consult around the world. As regard my certifications, I have a master's degree in information production and management. I am Microsoft certified data and cloud technology specialist. I am Microsoft certified trainer, which is known as MCT. I also have international computer driving license certification as a global trainer. So as regard my contacts, yes, I have my Gmail account, I have my LinkedIn account, I have my Twitter account, and my YouTube account. You can reach me on any one of these platforms, especially on LinkedIn. All right, so as regard my certification, I have a couple of certifications, which you can see. I've displayed just 9 of them. The 10th is just a Microsoft certification status, as somebody that is certified by Microsoft to take Microsoft certification courses. For more about my digital badges, you can see the link below. That's where you can have more about my certifications. All right, so as regard the module for today's trainee, it is just a 4 module course, which is known as DP 900 Azure Data Fundamentals. The course is being divided into key areas where concepts are being looked at and they are dealt with decisively. So for Microsoft, this curriculum was designed to be 8-hour class, which is a full day class, 8-hour class. And for the purpose of this training, I'm sure we don't have that 8 hours. I have requested maybe we can just have 2 sections for this particular course, this very one and the other one. So I will try to do justice to some of the key areas on the course. We have a challenge of the time because it's not a full-time session. So I'll just try to do how I can break down the entirety of the course into 4 hours. If we have the hours of 2 hours today, yes, we can do part one. And if we have another 2 hours, then we can do part two. Please, is this session 2 hours on an hour?
It is 2 hours.
Fine, thank you. So we'll be having these first 2 hours where we'll be covering the areas of core data concept and relational data in Azure. So in the subsequent edition, which is part 2, that you have to look out for, we'll be discussing on non-relational data in Azure and data analytics in Azure. All right, for study materials, yeah, there are 2 platforms for study materials. We have Microsoft Learn and we have PowerPoint slides. But as Microsoft certified trainer, we have what we call, let me activate my pen. We have what we call NDA, non-disclosure agreement with Microsoft that we should not share any of the PowerPoint slides with our trainees. So for that NDA clause, I will not be able to share the PowerPoint slides with you. I will have loved to, but there's a constraint. I will not be able to do that. But yes, as regards study materials, I will show you how you can have access to the Microsoft Learn, which is an open source learning platform. Go were the days when Microsoft official curriculums, we call it MOC, Microsoft official curriculums, were being paid for. Today, Microsoft has gone to that extent that, look, if you are very serious about digital learning, about digital transformation learning, that you don't need to buy those curriculum again. They are open source now. They have made it available for anybody to learn any kind of courses that you so desire. So in the course of this training, I'll be showing you how you can have access to DP 900 on Microsoft Learn. But for purpose of my presentation, I will make use of Power BI. I will make use of PowerPoint slides, which is the summary of the entirety of the curriculum. So my apology in advance that you'll not be having access to this PowerPoint slide. All right, so let me switch over directly to the first module, which is on core data analytics. Just a minute. All right, I'm trying to show module 1. Sorry. All right, module 1 is loading. Yes, module 1 has loaded. Let me share module 1. All right. All right, please confirm you can see module 1, fundamentals of data. All right. Yes, this module 1 is known as fundamentals of data. And when we're talking about fundamentals of data, we are looking from the perspective of somebody who is just getting to know about data. What do we mean by data? And what are the issues? What are the key concepts that are around data? That's what we are trying to achieve. So from this module 1, we'll be looking at the core data concepts and also data rules and services. All right, so what do we mean by core data concept? If you can see this particular page, we have this first question: what is data? From the meaning that we have values used to record information, often representing entities that have one or more attributes. There are 2 things that are involved when you're talking about data. There's a concept of data. Oh, let me activate my pen just a minute. There's a concept of data and there's a concept of information. Can any one of the audience, tell me the difference between data and information? You can try. You can unmute yourself and speak up. If you have information about the difference between the data and information. Yes, I want to make it as interactive as much as possible. Is somebody trying to tell us the difference between data and between data and the information?
There is no mic for the attendees since there is 100+ people, so they need to type it up. So it
Okay,
should be
that's
in the
fine.
chat box.
Okay, please, I will look out for your responses on chat box because knowledge is better shared from being interactive. So if I make it just one side, it will not be good enough that I'm dashing out everything that I'm not allowing you to contribute. I'm just looking at the chats if anybody has responded. Yes, thank you. I have Tapera, I have Evans, I have Kevin, I have Barry Hendrick, Bako, and some other people. They have said data is raw fact and figures while information is processed. Data is understandable and comprehensive. Thank you so much. I'm glad you have an idea about what we are about to discuss or what we are trying to discuss. Thank you so much. Now, the idea is that let me take you to my whiteboard. Just a minute. Let me take you to my whiteboard. Let me share my whiteboard. All right, so here's my whiteboard. Let me activate my pen. The idea is that, is there any difference between data versus information, right? As some of you have indicated, data is raw facts. We regard to data as raw fact, right? Which can also be represented by figure, right? When you're talking about representation by figure, it can be figure on what? On charts, which can be represented by figure on charts. Now, when you're talking about information, on the other hand, information is being referred to as what? Processed data. Processed data. All right, we are regarding to information as well as processed data. The idea is that, for instance, if somebody comes online and say, oh, this train that is going on, how many participants are in the house? We can say, okay, the total number of participants is 100. That is just a figure. That's just a data. It doesn't give information about maybe peculiarities about the attendees, maybe in terms of gender, maybe in terms of their knowledge, maybe in terms of academic achievement, maybe in terms of their characteristics. So it is just about the raw fact. 100 people are attending this training. Okay, we don't have further information about that particular data. So, but when we process data, like for instance now, okay, inside this training, we have 100 participants, and among them, maybe 90% of them, they have idea about data analytics, and 10% of them do not have idea about data analytics. That is the complete information. And that is why in most cases, people used to misunderstand or misrepresent data for information. And they do also misrepresent information for data. So, and that is why in the data profession, we make it as a duty that we let people be aware of the difference between the two. So the idea is that data is a subset of information. You can't have information without data. You can have data without information, right? But you cannot have information without data. So the idea is that data is a subset of what? Of information. I'll come back to this whiteboard. Let me take you back to the slide. Just a moment. Right, my slide. Okay, now that's what the difference between data and information is. When you are talking about data, we are reverting to what? Raw fact, which can be presented in terms of what? Figure, right? Or what? In terms of figure, in terms of table, in terms of what? in terms of charts, we have chart on graph. We get to know the cost of the string. Now, when you now have data, there are a lot of visuals that are available in your data, a lot of features. And that is taking us to how we can present on how we can store our data, how we can, the format of our data storage, or the format of our data availability. And that's what is being referred to as data can be presented in a structured manner. It can also be presented in a semi-structured manner, and it can also be presented in what? In a structured format. Now, what is now the difference between the three? We have presentation of data in terms of structured, in terms of semi-structured, and unstructured. This is one of the likely exam questions for whoever that is preparing for this examination, DP 900, DP 900. Please mind you, one of the prerequisites for DP 900 is what we call AZ 900, because DP 900 is about Microsoft Azure, and that's why we have Azure Data Fundamentals. There are a lot of concepts under is 900 that will be coming up under DP 900. So if you have not taken is 900, I want to implore you to also look at that, because a lot of concepts on data platform with regards to Azure there will be references to what to is 900. Okay, that's just a diversion, a positive one. All right, so we have three ways in which data can be presented: structured manner, semi-structured, and unstructured. Now, what do we mean by structured? By the time we refer to data as being structured, it means data that has been presented in what? Tabular manner. Tabular manner. When you have a data that has been presented in a tabular manner, like instance, we have, let us call this one 1. Oh, let us call this one A, and we call this one B. You can see that the data has been presented in what? In a tabular manner for A, and for example B, we also have data presented in a tabular manner. So now in this case, we now look at, for the structured data, we now look at some of the characteristics of that structured. One, data is presented in a tabular manner. That's number one. Two, data has what? Rows and column. Rows, this is row 1. We have what we call row 1. This is row 2. You can see that in row, we also refer to it as cases. When we refer to rows as what? As cases, whereby we refer to column as what? We refer to column as what? As entities. We refer to column as what? As attributes. As attributes. Because we are talking of tabular, we are talking about tabular. We have three important features. One, we have, for the tabular, we have what we call entities. Entity is the name of that table. For A, the name of the table is being referred to as what? As customer. That's the entity of that table. We also have attributes. Attributes are the column headers. When you are talking about attributes, they are column headers. Like we have first name, we have last name, we have email address, we also have maybe contact address. These are being regarded as what? Attributes of that table, which is also known as what? As entity. And the third thing that we revert to in a tabular way of presenting data is when we are talking about row. We have entity, which is table name. We have attributes, which are what? Which are the column headers. We also have the third one, which we refer to as what? As cases or rows. We refer to cases or rows. So those are the attributes of a tabular data, which we refer to as what? As structured data. Then the second type of data is what we refer to as semi-structured. From this word semi-structured, when you hear semi means halfway in between. That is, we have two broad categories. We have structured and unstructured, and we have one that is semi-structured. Semi-structured data is a kind of data that shares characteristics of structured and unstructured. That's why it's semi. Now, when you're looking at the aspect of structured, you can see that inside this, we also have, let me call this one C, and let me illustration C, and we have illustration D. Under his illustrations, this is illustration C, and this is illustration D. Under illustration C, you can see we have what? We have first name is Joe in quotes. We have last name as Jones. We have address as this. Now, you can see the part of the structured is that we also have a reference, which is first name as this, last name as this, address as this. Likewise, in the case of the structured, where we have first name as Joe, last name as Jones, email as this, and address as this. So that is the part of the structured of on semi-structured. Now, the other part of semi-structured, which is unstructured. It is unstructured because it has what we know as a programming syntax. You can see that it is all the data available here. They are being presented what in a programmatic manner. Why? Because you can see the curly bracket that is opening, and you can see the curly bracket that's also closing. You can also see some other syntax around the data that we are being entering. Yeah, we are entering. So, and this type of data is more of JSON format. That is JavaScript object notation. We call it JSON. So we have different type of data format, but this particular types of semi-structured is being denoted by what? JSON. And the idea is that, anytime you are talking about programming, presenting your data in a programmatic way, it means that we have to follow the rules of the syntax. There's what we call command, and there's what we call syntax. All right. Command is when you activate a particular action to be done. What are the syntax? Syntax are what are the steps that are naturally followed that command that you have called for. Like we don't have it in the SQL Server. Now, okay, maybe you have activated a select command. What are the things that follow that sequence of that command? So now in this case, the idea is that for semi-structured, yes, data has been is being entered in terms of what make use of programmatic data format. In that case, we have to follow the syntax. Can you see that when we declare a variable to be first name, we put the answer into what? Into quotes. So if for any reason the syntax is misspelled, or for any reason the syntax, any one of the syntax where you're supposed to use double quotes, you miss it, or where you're supposed to use colon, you miss it, or where you're supposed to use comma, you miss it. So you'll be subjected to error, which will require debugging and some other stuffs. So that is what we call semi-structured. In semi-structured, we have data that follows some part of the structured when we are doing variable declaration, and we have the other side that has to do with what? Programming way, which has to do, if you don't know programming, you can make use of semi-structured. We see the area of application of this in the course of this tree. So likewise, we have C, we also have it in D. Now for the unstructured data format, it is a situation whereby you have your data being not structured. We said data is structured, which means in a tabular format. Now we are now saying data is unstructured, which means data is not presented in a tabular format. An example of this is when you have what? You have data from different sources, such as maybe you have data from audio, we have data from audio source, we have data from text source, we have data from graphic source, and different other sources. So this is an example of what unstructured format of storing data. Now, let us have a look at this case, which is a E. Let us call this one E, and we call this one F. Now, can you see that for example E, we have a kind of text message, right? A kind of data is being presented in a text format. Dear Joe, thank you for ordering your hardware supplies from our online store, this one, and that one. Now, a lot of data are being embedded inside this text. Can somebody help us to identify some of the data that you can extract from this text? It's just like a mail. Somebody has ordered for a product, and a mail was being sent to that person for further information about what the person has ordered for. Can somebody help us to extract some of the data that we can see from this text? Please, you can drop your comments on the chat. Let me look for your chat. Thank you. Very entry. We can see order number. Yes. We can see order number. We can see delivery date. We can see customer name. Thank you. We can see product type. Yeah, thank you. Who's trying again? Can you see the mode of shipping? Can you see the mode of shipping? Can you see the ordering platform, which is online? We can see ordering platform, which is online. We can see the ordering date. Can you see the ordering date? The order number, we can see order number. Can you see the ship mode? Sorry, the shipping status. The shipping status that the product has been shipped, right? That's the feedback we are having. And can we see information about the arrival date? The arrival date is that it will take 3 to 5 days. So these are cluster of data that are being embedded into what? Into text. Like we have a case of what? Sending a mail to somebody that, okay, what you have ordered, these are details about it. So that's one of the ways we can present our structured data. I've mentioned 3 ways. We can have it in what? In audio format. We can have it in what? Text format. We can have it what? In graphics format. Like audio, the audio, maybe you have listened to a news. You can extract some important key information from what? For key data from what? From a news item. Or maybe it's a music, you can extract key data from what? From audio. Likewise, text. We have seen text. Likewise, graphics. Maybe you have an image of a product that is showing this and that. You can have a look at that. All right, so let us look at example F, where we have another text. And please, who can tell us which 2 type of data presentation do we have under this F, illustration F, which is contoso hardware? We have a mixture of what and what in terms of presenting data. We can try that. Is somebody trying? Thank you. We have text and graphics. We have text and graphics. Sometimes we refer to graphics as images. We refer to text as what? As images. All right, inside here, we can see that we have what? We have text and we have what? Addition of graphics. This is just a graphics on an image, which is just image of a spanner, of a screwdriver. Then we also have another image, which is what? A spanner. So the idea is that we can have a mix of different formats under unstructured data format. The idea about unstructured data format is when you have presentation of form of data in unstructured manner, that is not in a tabular manner, then it is not your duty to extract. From this F illustration, we can see different information about what? About the product that was sold, like a screwdriver. They also explain what the product is being used for. So there is information about what? There's a data about what? About the product name, which is a screwdriver. There's also information about what? Product job. That is, it is being used for tightening and loosening of what? And screen. Another data we can extract is that we also have product image. So we have product image. So the data we can extract from that is that we have product name. We have product name, right? We have product usage. Product usage, which is for what? Tightening and loosening screws. And we also have third information about what? Product image. We have product image, which is more in form of graphics. Then we also have riches. We also have other product information. We also have other product info. Maybe this is just an advertorial. That okay, we are doing an advert about the hardware we have in our organizations. We are pitching particularly a product name. We are pitching a product name, which is screwdriver, but we are also pitching some other products that we have in stock. So that's just a broad overview about data, about its structures. Let us move ahead. Now, how is data stored? When you're talking about data storage, we broadly have two ways of storing data, which are what? Data can be stored in file format, and it can also be stored in what? Data format. Now, let us see some of the ways we can present this. Now, when you are storing data in a file in files, we have different ways we can store data in files. We have what we call delimited text. We have uh, notation. We have JavaScript notation, the likes of what we just saw under unstructured data. We also have data being stored in XML5 format. Our standards can also be stored in terms of blob. By the time we are talking about blob, we are talking more about Azure blob. We get to know more about it later. Azure blob data storage. So our data can be stored in Azure blob format, and our data can also be stored in what? Optimized format. Optimized format. Now, the idea about optimized format is that I have a particular case study where your data size, your data size, uh, your data size is 25. Your data size is 25 gigabytes, but you have a storage size of 20 gigabytes. If I ask you, is it possible to store a data that has 25 gigabyte size on a storage size of 20 gigabytes? Is it possible? Is that possible? Let me just hear your feedback on the chat. No way. No way. Chinedu said no way. Haha. So it is not possible that we store a data size that is bigger than the storage capacity. It is not. Now, when you're talking about optimized format is just a kind of technology that we can make use of to reduce the data size. We want to reduce the data size through which it can now be stored on a smaller storage size. Are you getting the gist? When we make use of optimized format, we are trying to reduce our data size to a more storage size that can be accommodated by our storage medium. So that's just about that. Now, there is a concept that we know as big data. The concept of big data is when you have a data set that is running into millions of rows or millions of rows or cases or billions of rows and cases. With the advent of IoT, Internet of a Thing, we have possibility of having data in millions, in what? In million cases and in billion cases. And from there, the concept of big data came up that, it's like the world is generating big data. What are the kind of technology that we can, we can provide for people to store their data, by compressing the size of the data into a smaller size. So some of those optimized formats are what we call Afro, ORC, and Packet. But among them, the one that is majorly used is what we know as Packet. When you go to advanced analytics in Microsoft Azure, you will come across what we call Azure Synapse Analytics. Azure Synapse Analytics, where you do big data, you do processing of big data. Whether you are a data engineer, you are a data scientist, or you are a database administrator or data analyst. So you have a common platform that is known as what Azure Synapse Analytics, which make use of Packet file format in order to save, to minimize our storage size. All right, so those are about when you're talking about delimited text, we are talking about flat files like a case study of our CSV file, comma separated CSV. No, not this one. CSV, comma separated values. And the example of our Excel, when you're having your data in Excel, or you're having our data in what? In comma separated values. So these are examples of delimited text. So we also have shown the example of JSON. There are also examples of these. We also get to blobs, and I've explained about this. All right, the other side of data storage is broadly known as database. Data can be stored in file format, and it can be stored in what? Database format. Those are the two broad ways. Now, if data is being stored in database, there are two ways of doing that. The first one is relational database. Our data can be stored in terms of relational database, and our data can also be stored in form of what? Non-relational database. Now, the next thing is that what are the properties of a relational database? Let me try to clean up. Let me try to clean up my space. All right. All right. So the idea is that what are the all right. What are the under database? Our data can be stored in terms of relational, and second one in terms of what? Non-relational. So what are the difference between them? The difference between them is that when you are talking about relational database, from the English word relation, it is talking about a database. You know, database is composed of what? Is composed of tables, right? Database is composed of what? Of table. And that's why we have customer table, we have product table, we have order table, we have line item table. So that is what? That is a database. All right. So what now make it a relational database? What make it a relational database is that when you have a set of tables in a database that share a kind of relationship, that is, they are related in one way or the other. For instance, now you can see there is this line, that's this line of connectivity. There's a line of connectivity between customer table and order table. There's also a line of connectivity between product table and what? And the line item. There's another connectivity between order table and what? And line item. Now, in some advanced, but before I go from that statement, but there's no direct connectivity between customer and products. There's also no direct connectivity between customer and line. So the idea is that we have direct connectivity, and we have indirect connectivity. Now, what do you mean by direct connectivity? Direct connectivity is that once there is a connectivity between one table and the other, that is a direct connectivity. Another way is that there could be indirect connectivity. For instance, from the customer profile, this is just a customer profile table. I may wish to know which line item was bought by a customer under what product, under what product, under what product. For instance, I can say, okay, I want to know, I can do a query, which customer bought what. For instance, now, if it is about what's the product that was bought, and I'm relating to customer, I can look at the customer ID and also go and look at product table. So, and there's no direct connectivity between customer and product. So the way I will go about it, the way the sequence we do is that it will move from the customer table, go into order table, from the order table to a line item table, and from the line item table, get the information for me in terms of what? From the products table. So that's the indirect connectivity. So the idea about relational database is that one, we have different tables. We have data that are presented in different tables. That's point number one. Then point number two, there is relationship, or what we call connectivity. There's connection. There's connection between tables. There's connection between tables, whether direct connection or indirect connection, like I've explained. The third thing about relational database that we have to note is that If it is a direct connectivity, we must have what we call primary key, and we must have foreign key. Primary key is from which table are we coming from? That's primary key. From which table are we coming from? To which table are we going to? That's the primary. So from where we are coming from, we are referring to it as primary key, and the table we are going to, we are referring to it as what? As a foreign key. Now, before we can establish relationship between data, we must have what we call a particular column or a particular entity that is being shared on the two tables. For instance, now you can see there's a customer ID here. Then if you go to this is under customer table or customer entity. If you go to the under entity or other table, there's also customer ID. This customer you are seeing is the same thing as customer ID. So the idea is that before you can have relationship between two tables, you must have a particular column of reference that is available in the two tables of interest. So in this case, in terms of customer table and other table, we have customer ID that is common to the two. So now we can see that from the table shown to us, we don't have direction. And that's why in advanced analytics, like a case of PA300, which is making use of Power BI for data analytics, it tells you that if you are establishing relation between two tables, two things are important. We must know cardinality. Right? And we must know the flow. We must know the flow of the movement, the flow of the table. The flow has to do with, are we moving from here in this direction? The source is customer table. Then the target is what? The target is what? Other table. Or we are moving other side, whereby we have source as our what? As our other table, and we have our destination as what? On target as well as customer table. So in advanced analytics, there's what we call cardinality, and there's what we call the flow of the relationship, because they have effect on our analytics. So this is not subject of today's discussion, because this is just a beginner's class. When we have privilege of moving to that level, that should be explained in details. Then the third thing, so if customer table is not our source, so we now have customer ID as our primary key, and what? Customer under other table as our what? As our foreign key. So that's just the illustration. There's a concept around it that we discuss later on this. Then fourth thing that we must know about relational database is it is also being referred to SQL database. We refer to relational database as SQL database. So those are the four properties of a relational database. One, it has tables, which are customer table, like example of customer table, product table, this one. Two, there is connectivity, or there is a kind of relationship that is being shared between the tables available. Then we also have what we call primary key and foreign key within the relationship that we are looking at. And we also have what we also refer to relational database as what? SQL database. So these are some of the characteristics of what? Of relational database. All right, let us look at non-relational database. When you are talking about non-relational database, of course, it is the opposite of relational base. Now, we are talking about table. We are talking about a database, not one. We are talking about database not presented, not in tabular format. Are we getting it? We are talking about a database that is not presented in the tabular manner. Another thing about non-relational table is that no relationship exists Of course, from the word no relational, no relationship. No relationship exists between the tables. Between the tables. All right. The another thing you have to know about our non-relational database is that we have different ways of presenting it. And those ways of presenting it are what? We have key values. We have key values. We have document. That is, our non-relational database can be presented in terms of what? Key values. It can be in form of what? Documents. Right? It can be in form of what? Column family. Column family. Column family. It can be in terms of what? It can be in terms of graph. So those are the 4 ways through which we can present our non-relational database. Now, what do we mean by key value? What do we mean by document? What do we mean by columnar family? And what do we mean by graph? Now, what we mean by, when you're talking about key value, is such a situation whereby we are making use of a particular key. Like in terms of, if you have ever seen a map that has legend, that has key and legend, that is, wherever you see this color, this is what it means, or wherever you see this value, this is what it means. So this is a similar case of what? Key value. The meaning of the key is that wherever you have seen this, we are representing by what value. That's the meaning of the key value. For instance, under product table, wherever you see 1, 2, 3, the meaning of it is that we are referring to a product whose name is Amma and whose price is $2.99 US. Or wherever you see a particular ID, which is which we refer to as key 162, it means we are referring to a particular screwdriver that has a price tag of what? 3.49. Are we together? So likewise, if you check this product under the relational table, if you check this product, you can see we have one that's 1, 2, 3, which is what? Armor at this price. There's also a product ID, which is 203. You know, the meaning of it is what? A wretch. A wretch. From here, it is a wretch whose price is $4.25. And we have another one, 1, 2, 3, which is the same thing as this. That's what we mean by when you are making use of a particular value, when you're making use of a particular key to represent a value. That's the meaning of key value. When you're talking about documents, documents is when you are presenting your table in terms of what maybe making use of a programming language like JSON programming language that you are having better information about different particular tables in terms of programming language. That is more of document. Then the fourth one is columnar family. Now, in the case of columnar family, the idea is that you are having a combination. Instead of having different tables, you are now having combination of tables together. That is columnar family. One, you can see that there are some peculiarities as regards each product. So if you now combine all those peculiarities together, then we now have what we call column family. For instance, under this illustration, I can see customer name, customer address being joined together by product profile, which is a product name and product price. So it is a case study of a columnar family. Then the fourth representation is what we know as graph. Now, from this graph, we're having images representing communication. For instance, now, we have two personalities. We have Ben, we have Sue. From the arrow, we are informed that Ben is reporting to Sue. Maybe Sue is the upline manager to Ben. But the idea is that both Sue and Ben, they work at the same department, which is hardware department. So, but the line of communication may be that Ben is being supervised by Sue. It means that Ben has to pass information through Sue before it gets to department, which is what the hardware department. So that is all. So the idea is that we have the graph, we have the image on the graph, and we have the direction of the flow of movement. All right, so we have discussed about that. There's what we call another concept. There's what we call data workload. Data workload. Now, when we are talking about data workload, we are talking about what we have in our data set, and how this data set is being managed. Broadly speaking, there are two ways of data workload. Our transactional data workload. That is, anytime we conduct a transaction, how our data look like. There are two ways to it. There's what we call OLTP, and the second one, the first one is OLTP, the second one is OLAP. OLAP. Those are the two ways we can have our transactional data workflow. For OLTP, OL means online, T means transactional, and P means processing. That is OLTP. The other one, OL means online, A means analytics, and P means processing. The idea is that we can have two types of transactional workload. The one that is just entering and the one that has possibility of what? Of analytics. So this one is just entering. Data is just entering, and we can work around the entries that we have. We can check and accommodate. But in terms of analytics, as data is being entered, we can perform some analytics on it. So those are the two types of what transactional workload, data workload that we have. Now let us see properties of the two. Let us see the characteristics on properties of the two. Now, in the case of OLTP, which is online transactional processing, the idea is that, one, it is a mix of read and write activities. You know, I've said that for OLTP, data is entering. And when data enters, maybe into our database, this is the symbol of a database. So our data, and how data is being entered into the database, we have customer. Let us make use of a bank. Maybe this is the database of a bank, right? This is the database of a bank. Now, this is the customer. Now, each time a customer goes to maybe the website of the bank, or maybe the applications of the bank, or any other transaction platform of the bank, you know, there's a kind of exchange of data from data entry and from data output. Now, okay, look, maybe me, I've requested for my account statement, account statement, my bank account statement, right? For me to get feedback, I will have logged in maybe into my portal, my account portal, and now make request, sending my request to what? To the server. I will send my request to the server. That's the one way. The server will now give me feedback, and that's what make it doer. It goes on and it goes back. Okay, look, Popola, this is what you have in your account that you have made a request of. So that is about that. Now, when you're talking about OLTP, it has possibility. Now, anytime a transaction occurs, like this, anytime a customer make use of that platform, it is being recorded. It is being recorded in the database. And that's why we have what we call login. We have what we call login, login information. That is, who has gotten access to our database, or who has made a request from our database, and what is that person looking for? Then are we able to, provide the required information or not? Those are the kind of details that we have at the back end. Someone, our database server is more at the back end. All right, so the case is that when you have OLTP, it means that you can only read and write, but you cannot do the third one, which is what? Analytics. You can't do analytics. Analytics is no for OLTP. You can only read. The meaning of the reading is that you can check the values or the entries that you have in the database. And the meaning of the write is that you can have new information, new entries. Maybe somebody is making a new entry. That is, it can write this new entry. But if you are checking what has been available before, you are just reading from what is available. Then another property of OLTP is what we know as what? ACID. By ACID, we means A for atomicity, C for consistency, I for isolation, and D for durability. How do we mean? By the time we are talking about atomicity, for somebody that has studied maybe chemistry or biology, when they are when they are describing what is an atom, they will describe atom as the smallest unit of an element. Can you remember? Yes, your old school elementary science. So we can describe an atom as the smallest unit of what? Of an element. Now, when your transaction is performed, it has these characteristics. And by atomicity, we mean that each particular transaction is treated as a single unit of work. For instance, now, maybe in my bank, they have different platforms for operational service. They have USSD. That is where you make use of shortcode. One. They also have what? Applications, mobile applications that you can make use of for transactions. They also have what? Third one, maybe they also have browsing. They have web link. They have web link. They have at least they have a website. That's okay. Anytime I want to perform operations, we can go to anyone. Now, if you are trying to be too smart, you have a single account, you want to access it at the same time using different platforms. You want to use USSD platform, you want to use application platform, which this application platform can be maybe from your Google Play. From your Google Play, you downloaded it, or from your iOS Play Store. So you also have what? Web link. So if you are trying to be too smart, that you want to access your account at the same time and making requests for different things, now there's no way it can scale. There's no way it can work. It can scale through, because for each transaction that you have initiated, there will be an ID that will be attached to each one of them. And look, whoever is trying to access the account is making use of USSD. There's a difference in code. Whoever is trying to make use of the account is trying to access through what? Through the applications, or is he using web links, that is web access. So for any kind of transaction that happens at any point in time, the platform, which is OLTP, looks out for the single unit of work, and whether that unit of work is to either be done completely or it fails completely, whether it's successful or it fails completely. All right. For consistency, by the time we are talking about consistency, we are talking about the data we are taking in. For instance, if we have a particular table that is taking data, maybe in terms of the customer name, maybe in terms of customer request, maybe in terms of customer feedback, or some other things. So there's consistency about what a database is looking for in terms of what online transactional processing. There's what we call isolation. Yes, there could be concurrency transactions, like a case study that I just cited. It's a concurrency transaction. You have 3 platforms that you can reach out to your bank, and you want to make use of it at the same time. There's what we call concurrency transactions, cannot interfere with one another. So it means that when you are trying to approach different platforms, they will not affect one another, but they will be noted that your request is from this platform and this is the code attached to it. We also have what we call durability. By durability, we are talking about how long can our database in OLTP transactional workload, how long can it be stayed without changes or persistency in changes in the database. All right. So we have just looked at what OLTP. This time around, we want to look at what analytical data workload. So we have transactional data workload, which is OLTP, and we have what? Analytical data load, which is more of what? OLAP. Now, in OLAP, let me make use of this illustration in OLAP. Now, your data can be stored from different sources. It can be saved inside different sources. Like the example that I have given to us. This is what is just this particular one. Our data source here is what in a tabular format. This is structured. This is structured data format, which is also known as what? Relational data format, right? Then we also have our data being stored in what? In files. This is the symbol of the file, and this is the symbol of what? Database, which is what? Of relational database. Now, if we have different data being stored in different platforms, we can move the data into what we call DL, which is known as what? Data lake, which is known as data lake. We can have, once you have your data from different sources, you can put it in data lake, which is the first step. And from the data lake, you can now extract the data you need and push it. You can extract data you need. Maybe you do transformation on them, or you don't do, depending on your request. Then you can now push it to what? Data warehouse. We are talking about data warehouse is another big concept that is talking about an enterprise level data platform. So now, by the time it gets to data warehouse, you have extracted all the things that you need. All right, so you can now do what? Analytics around it by having them in aggregates. We call this one aggregates. We call it aggregates. By aggregates, we are talking about sum up. Okay, I want you to sum up sales maybe by location. I want you to sum up revenue by location, or I want you to sum up these particular things as regards to one or two variables of interest. So by the aggregation, we are making use of a platform that is known as what? That is known as what? As a cube. As a cube. Then from the aggregation, we are now presenting, aggregation is this, we are now presenting our data in different formats. So this one is what? Data presentation. Presentation, which is more of what? Data visualization. Which is more about data visualization. All right, so that's just the idea about how we can get. So now if you're not talking data visualization, there are different charts that we can make use. The first chart is about what? About column chart. This particular chart is talking about line chart. And this particular chart is talking about what we know as KPI, Key Performance Index. And the idea about KPI is that we want to know if we are meeting up with targets or we are not meeting up with the targets. So if we are meeting up with targets, it will indicate green color. And wherever we are not meeting up with the target, it will, and that for meeting up in target, it will show green color and it will point arrow up. That is, oh, we have done above the threshold. But once we have the red and it's pointing down, it is showing that we are far less to reach our benchmark. To reach our benchmark. So that's just the idea about that. So from there, we now move to how user. This is just a user. How user can now view our presentations. This is just a presentation in form of what? In form of a pie chart. So there's a knowledge check. Who can answer this question very correctly? How is data in a relational table organized? We just have 2 minutes for this exercise. Is anybody replying? Is anybody replying? Rosa column. Thank you. For question number 2, which of the following is an example of unstructured data? Who is answering that? The first person to say it correctly. The first answer, yes, we got it. For the second question, answer B, yes. The correct answer is B. For the third question, what is the answer? What is a data warehouse? What is a data warehouse? Please, if you are responding, put 1 if it is A, put 2 if it is A, put 3 if it is A. Yeah, for question 3, I'm on question 3. What is a data warehouse? David, you just wrote 3. Your answer, no idea. Write 3, then if it is A, if it is B, and if it is C, then I will be sure that you know what we are saying. Michael said 3 is B. Habakkuk said 3 is C. Likewise, Kavi. So, all right, just for your big feedback, let's just quickly check that. If we the correct answer for A is correct answer for 1 is A, correct answer for 2 is B, and correct answer for question 3 is a relation database optimized for read only. All right, so now let us look at data roles and services. Data roles and services. Under these data roles and services, yes, gone were the days when you hear about data, you think of 2 professionals. One, you think of maybe a mathematician, or somebody that is what? Statistician. When you're talking about data professional, gone are the days when you think maybe somebody that is a mathematician or somebody is what? Statistician. Gone are those days. In the present time, because ICT, information and communication technology, has been added to math, we now have a new set of what? Data professionals. And among them, we have database administrator, we have data engineer, we have data analyst. Some other roles, some other data professional roles that are not stated here. I can give you some examples. We have data scientist. We have data scientist. We have machine learning experts, right? We have AI. We have AI specialist as other data roles. So the more you are moving to the upper ladder of the upper side of the ladder, the more you get to know more about those details. So, but for the purpose of this training, because it is still a fundamental course, so let us do away with those advanced ones and restrict ourselves to the fundamental. So for the purpose of this training, they want us to have idea about what? A database administrator, a data engineer, and data analyst. So what are different roles? If you are from some part of the world, you will see some job adverts, right? That is job advertisement. They will advertise for a particular data role, maybe data analyst. There is a job role that is mainly for data analysts. And from their criteria, job responsibilities, they will also say, okay, apart from being a data analyst, you must also be able to do some things under data engineering. You must also be able to do some things under database administrator. And that's the case study of Nigeria, my country. In my country, you have some business owners, they are looking for data analysts, but they are also saying, you're a data analyst, you must also be able to do some other things that data engineer does or that database administrator does. So it now makes it more complex that, look, your line of thought that is of data analytics is not enough. You also need to acquire some knowledge about other areas of data professions. So, but in a more stabilized environment, the idea is that if you're a data analyst, yes, we only hire you for a data analytics job. We're not asked you to go and do the job of a data engineer or a job of data administrator. And that's why there's a need for limitations about what are the job roles of each one of them. Like a database administrator, the job is about data provisioning, configuration management, database security, user access, issues that has to do with what? Access, granting access, database management, provisioning, and optimization. But when you're talking about data engineer is they are the one that are into data integration pipeline. That's what we call integration pipeline. We meet it maybe in the next class. There's also what we call ETL. ETL means extract. E for extract, transform, and what? Transform and what? Load. So there are two ways we can do data engineering. We can make use of ETL, or ELT. That is, loading comes before transformation. In this case, it is transformation that comes before loading. So we discuss that concept later. So the idea is that we are extracting data from a source. Maybe we have observed the need for data cleaning or data transformation. Then we are doing data transformation before we now load it into the analytics tool. Or are we saying we're extracting data immediately, we are loading it directly, and thereafter we are now doing transformation? So it depends on the way we have structured it. So it's also part of the data engineer job to do data cleansing and transformation. Also do data analytics, store schemas, and what? Data load and data loads. Whereby the major role of data analysts are analytical modeling, data reporting and summarization, and data visualizations. But in some environments, it is not enough. They will ask you to also know more about some other professionals in your field of study. All right, so we have what we call Microsoft Cloud Services. Now, we are coming from generic to specific. The idea is that data analytics we have been doing it more on-premise, but the world is moving into the cloud-based environment. Cloud environment. The idea is that we have been doing more of data analytics on premises. By the time we are talking about on premise, it's like maybe we are making use of our laptops, and we are making use of our data center, maybe data center in organizations. We have access to the data, we are processing it, and we are making use of its end results. So, but data is now being moved into the cloud, and that's why there has been a lot of data migration in terms of the platform recently. And the idea is that we have different cloud service providers. We have different cloud service providers, which Microsoft is one of them. We also have Google GPC. We have Google GPC. We have Amazon AWS. We have some other service provider, cloud providers. But as regards Microsoft, in Microsoft, the platform that has been provided for data analytics is in the Azure. And under Azure, we call it what? Data platform. Data platforms. Data platform. We have different data platforms in Azure. What are those data platforms? Maybe data engineering, maybe database administration, maybe data science, or maybe database administrator, maybe data analytics. We have those data platform in Azure, which is the cloud-based environment for data analytics. Now, broadly speaking, we have some services. We have a lot of services that are for data platforms. We have more than 40. We have more than 40 services for data platforms in Azure. And some of them have just been listed. We have those ones that are for data storage. We have those ones that are for data engineering and analytics. We have those ones that are for data engineering and analytics. For data storage, which is more about what? It is more about database management. This is about database management for the data storage. But this one, we have combination of what? Data engineering and data analytics. Now, what are the tools we use for data storage on database? So these are some of them. We have Azure SQL. We have Azure Database for open source. We have Azure Cosmos DB. We have Azure Storage. For what? For data engineering and analytics, we have some other services like we call this one ADF, which is more for data engineering. Azure Data Factory is for more data engineering. We have Azure Synapse Analytics. This Azure Synapse Analytics is a one-stop shop for all data professionals, whether you are engineer, whether you are a scientist, whether you are analyst, whether you are database administrator. It's a one-stop shop for all data professionals. We also have Azure Database, which is more for data engineering. We have Azure HD Insight, We have Stream Analytics, we have Explorer, we have Microsoft Purview, we have Power BI. Power BI is a major tool. In fact, it's the greatest tool for data analytics. All right. So I said we have more than 40 services that are for data platform in what? In Azure, data platform in Azure. We get to know by the time we are taking a practical section on that. Okay, for knowledge check, question 1, please, if you are responding, just let us pick 1 if it is A, B, or C. Question 2 if it is A, B, or C, so that I'll be able to relate your responses. I'll be able to relate to your responses. All right. So who is trying? For question 1, who is trying? Michael said question 1 is A. There who is saying something else. I have Jabo. Jabo said 1 is A. Okay. All right. We have enough feedbacks. For question 2, what is the answer? What is the answer for question 2? What is the answer for question 2? Michael also said question 2 is B. We have Tuli. Tuli just mentioned B. I know you are referring to question 2. Then I have feedback from Timothy and Kundida. I'm sorry. Evans is sharp guy. Evans has provided answer to all. For question 3, yes. What is the answer for question 3? Int said question 3 is the answer is C. Unketo also says C. I have Chinasa also says C. I have Kensi also mentioned C. Okay, let's check. Let us cross check. The answer, question 1 is A, question 2 is B, and question 3 is C. So I'm glad we are all moving at the same pace. We have reached the end of this module, and our time is fast spent. I usually take time under this module because it is the foundation of what next. So if there's anybody that does not get it correctly, there may be challenges when we are talking about module 2, module 3, and module 4. But let's just see how far. We have about 7 minutes. Let's see how far we can go on question 7. Sorry, on module 2. Let me just project module 2. I have idea about it so that maybe we'll follow it up in the next presentation. Suraj, is it possible to have extra time or just 2 hours? Straightforward.
I'm sorry for the start time.
I said, is it possible to have extra time or just 2 hours? Straightforward.
Sure. If the attendees would like to be having.
We can have extra time?
Yes, if the attendees like to be having it as well. So.
Okay, that's fine. So let us quickly look at module 2. In module 2, we are talking about relational database. If you can recall where we are starting from, we are starting from generic to specific. And what we started from generic is that we define in module 1, we define what? Core data concepts. We define core data concepts. And some of the concepts that came under that was what do you mean by data? What do you mean by information? What do you mean by information? Those concepts is about also our storage, our data storage, which can be broadly divided into 2, which is files and what? File and database. We also discuss about what? Also discuss about relational database and non-relational database. Can you remember? We discussed about relational and non-relational database. So those are fundamental concepts of data. Now, we are now looking to specific. And for specific, you want to look at is what we know as relational database. We want to look deeper into what we know as what relational database. Let me clean up. Let me clean up very quickly. All right, so by the time we are talking about relational database, what are the core objectives that we want to achieve? One, we want to see concepts, data concept on relational database, right? We also want to see how we can make use of Azure services for what? Relational database. Those are the two things we want to look at. Okay, now under the relational data concept, now I've well explained about relational database the other time. By the time you are talking about relational database, we are talking about a database that has collection of tables, right? Collection of tables in which data are being stored, and that also has possibility of what? Connection, relation, that is relationship exists between two tables. And those two tables, what we make use of identifying the relationship is when we have primary key. Can you remember? Primary key and what? Foreign key. All right. So we also talk about maybe at some other advanced level, maybe the cardinality. By the time, okay, I didn't mention the cardinality the other time. By the time we are talking about cardinality, we are talking about is it one? Is it the relationship that we are talking about? Is it many to many? Is it many to one? Or is it one-to-one relationship? All those concepts are more of their cardinality stuffs under relationship, under data, under what? Under relationship database. But they are not for fundamental course. Now, the idea is that there are some properties that we must know about relational table. One, data is stored in the table. Data is stored in rows and columns. All rows have same columns, which is correct. Like this row 1, it has the same column as this row 2. Then each column is assigned a data type. Yes, on this data type stuff, let me quickly explain that on the on my noteboard, because people used to make a lot of mistakes around that. Let me quickly share my my notes, my whiteboard. Just a moment. All right. So this is my whiteboard. All right. Let me move this to one side. The idea is that we have what we call data type. We have different data type. They are not limited to what I will write here, but I just want to give an illustration. Different data types. We have what we call whole number. We have whole number data type. We have decimal data type. We have text. We have text data type. We have what we call Boolean, which is a Boolean data type, which is in some analytics we call it a dichotomous data type. That is, it is either A or B. For instance, it is either true or false, or it is either yes or what, or no. So we have different data types that we have. We can also have data type in terms of what? In terms of date, especially when we are talking about time intelligence data. Now, the idea is that this is the illustration I want to make about this. Now, imagine you have somebody that, we are talking about the product of a price. The price of a product. Maybe the price of a product is 20.91. Now, when that person now tries to do data entry. For this 20.91, example of whole number is when you have 1, 20, 30. Example of decimal is when you have any figure that is taking decimal place. All right. Example of text is when you have just ordinary text, and those are examples. Now, in this case, the data type for this example, which is 20.91, is what? Is decimal. It is the decimal data type. Now, maybe somebody during the course of data entry now made a mistake. Instead of typing figure 2, figure 0, the person now type figure 2 and O for orange, letter O for orange, and now type 91. You know, error has been introduced, and the error is by converting a numeric to what? To text. Now, the implication of that is that when you are doing calculations or you are summing up a particular column, so if a particular column for any reason contains two types of data set, like this case now, we have what? We have decimal combined with what? With text. There will be an error message. And the error message will be what? Error due to data type. So the idea is that in analytics, each one of the column, right, which is being regarded to as entity, must be represented by a single data type. Because if you mistakenly combine it and unfortunately you come to do a kind of calculations, there will be an error, and the error will now be what? Due to data type. And that's the import from that statement. Let me take you back to the slide. That each of your presentation should have what we regard to as what? A particular data type of interest. A particular data type of intent. And that's why they said each column is assigned a data type. No column should have more than one single data type, because the implication of that is that by the time you are doing some calculations, there will be some type of error. I think that concept is clear. Now, something that we also need to do is that when you're talking about relational database, relational table, we're also thinking about what? Primary key and foreign key, which we have also discussed the other time. Then there's also a concept of normalization. There's a concept of normalizations. And in the concept of normalization, we are thinking about how do we normalize our data set. For instance, let me give you an illustration. Maybe an enterprise level retail company, maybe ShopRite. I'm aware ShopRite is common in most countries, which is into retail services. Now, maybe in ShopRite, anytime a customer comes into the office to buy things, they have a spreadsheet where they collect all information about what? About a single transaction that is done. One, they will collect information on what? Customer profile. They will collect information on what? On products. They will collect information on products. Sometimes they will collect information on what? Location. Right? Sometimes they collect information on what? On order. Now, how does this relate? Now, I go to a ShopRite to buy a product, maybe just a shopping mall, It can be any shopping mall. And immediately I enter. Now, by the time transaction is being done, they are collecting by the time they are doing, they are entering their sales data. We call it sales data. Now, they want to know customer profile. Like for instance, they want to know my what? They want to know my first name under customer profile. They want to know my last name. They want to know my address, and they want to know my what? My city. Under product information, this product info, they want to know which product have I bought, which category does it belongs, which subcategory does it belong. For instance, now in Nigeria, if I've gone to a shopping mall and I've gone to beverage, I've gone to buy beverage, right? The category of that product is what? Is beverage. And other beverage, we have different classes in Nigeria. We have what we call Milo. We have what we call Bonvita. We have Bonvita. We have Vita, this and that. We have different brands. We have different brands. That's product category. The category is beverage, right? Subcategory is which of the brand of that product am I buying? So they also look at it. Then they also look at some other product information. Maybe under that product brand, am I buying a tin type? Am I buying a tin type? I'm buying a refill type, or I'm buying that's what we call sachet. That's what we call a sachet. So, those are for further information about what I've come to buy. So all those ones are other product information. Under location information, they may likely to know, oh, which of the location have I bought the product? Maybe in terms of the country, maybe it's a multinational company. They're more likely to know, okay, this purchase that was done, it was done in Nigeria. It was done in Nigeria. The next thing is which state in Nigeria. The next thing is maybe which city in Nigeria. The next thing is all those geographical information. So that's about location information. Another thing that can happen is about order. In the order, we are talking about maybe the order number, order item, maybe the quantity, and some other information. So other product information can also have what? We can also have quantity, and other stuffs under that. So the idea is that what normalization does is that instead of having all this information presented in a single table, that will be difficult for us to break down in terms of looking for smallest units of information from the table. Why can't we break them down? Why can't we have customer provide table? Why can't we have product information table? Why can't we have geographic location information table? Why can't we have other information table? The benefit of that is that whenever I'm looking for a particular information for analytics, then I will just go to that I will just go to that table that has that specific information. For instance, maybe I want to look for a customer whose city is New York. I want to look for a customer, or I want to know, okay, how many customers do we have from New York City? If it is within this lengthy of information, I can't access city because city has been embedded. Can you see? Can you see this illustration? City has been embedded under what? Under customer, which is a New York. So there's no way I can extract New York from this kind of arrangement. And that's what normalization does. That, look, let us break down this information into what we call entities so that we can be able to move to different entities as regards our analytical need of it. For instance, now, I can project this customer table to now have different headings as Joe as the first name, then Jones as the last name, then one main street as the what? As the address, and the city as this. Altogether, now other products, I can say product name, this is product name, this is product price, and I can now have product quantity, the quantity purchased. So this one will give us, for instance, now you can see that there will be a challenge. If I'm looking for a product from this table, from this sales table, I'm looking for a product that is sold 2.99. You can see that a product that was sold at 2.99 is just an hammer, but I cannot trace it out because that sales value has been attached to a product name. It will be difficult to extract. But if we have done normalization, it means that we have broken down a single sales data into different entities. Then it will now be easier for me. Can you see the product? Can you see the product? Can you now see the product entity? Of course, if you are asking me about the product that has a price tag of 2.99, it is easier for me than for me to go and look for it from sales data. So the idea about normalization is we are looking at the way of breaking down a long list of what? Of a table into smaller units, into smaller entities that can be easier for analytics. In advanced analytics, there's what we call fact and dimension table. Fact and dimension table. Fact table is a table that has all the details. Like this says data. That's our fact table. It has all the details of transactions. But by the time we are talking about dimensions, dimensions are just entities we have broken it into. Those are the entities we are broken into. So the dimension that we can have is we can have dim, we call it dim, dimension customer. We have dim product, dimension product, dim order, dimensional order, dim line item, dimension line item. So there is a fact and dimension tables. We have fact table as a single source of the truth, where we have dimensions as well as the entities we are broken it into. Now, if you look at these notes they have sent here, we have separate each entity into its own table from the main table. Then separate each discrete attribute into its own column, like we have for customer. We have customer first name, we have customer ID, first name, last name, address, and city. Then uniquely identify each entity instance in terms of row using a primary key. Now, when you look at each one of those, entities, and you now look at each one of those attributes, the one that has unique identification, like in terms of this product and in terms of this customer ID, a customer cannot have two IDs like an employee. If you're an employee of a company, is it possible you have two ID? It's not possible. Or you are a student of an institution, is it possible to have two matriculation numbers? It is not possible. So when you look at a unique ID, that unique ID is being referred to as what? Primary key. Primary key. And when it goes to the other columns, like this, where we have customer ID, when it goes to the other column, we refer to it as what? As foreign key. Okay. We also have what we call structured query language. We are moving gradually to our destination. We have what we call structured query language. In structured query language, this we call it SQL. This is a common platform for all data professionals. SQL is a common platform for all data professionals, whether you are a data analyst, whether you are a database administrator, whether you are a database, whether you are a data analyst or data engineer. What is common to everybody is the SQL, because SQL is the language of data platform. Now, from the SQL query, we refer to SQL as what? Structured query language. Some people call it programming language. It is not a programming language. It is what? A query language. It is a query language. Like also we have recently in Azure, we have Costo. We have, is it Costo? Costo query language. I've forgotten the spell of this. Is it Costo or something like that? But the meaning of it is KQL. We call it KQL in some advanced analytics. It's also a query language, which is being used for some advanced analytics. So the idea is that S stands for structured, Q for query, and L for language. Now, this language is being maintained by what? International organizations, the likes of ANSI, which is from America, and the like of international standard organizations. The idea is that, okay, we want to build a platform where data professionals can relate together. It has to meet up with a standard. And that's why two international organizations are maintaining those standards for people to, to relate and to work with. Another thing you need to know about SQL is that we have some of them that are, open source, and we have some of them that are what? Proprietary. Some of them are open source, and some of them are what? Proprietary. Like the case of Oracle, the case of Microsoft SQL Server Studio. Like the case of Oracle is proprietary. If you want to use database in Oracle, it is proprietary. You have to pay for it. But if you want to use SQL, you want to use SQL Server in Microsoft. We call it a Microsoft SQL Server Studio. It is what? It is an open source. And another open source that we have, like the issue of MariaDB, and Postgres. So these are open source. But with the Microsoft, it has taken note in Azure that some database were, designed with open source, but how can they be also be migrated into the cloud? So that's why in Azure we have some open source, database platforms that have been embedded into it. Now, most RDBMS, that is relational database management systems, support proprietary extensions of what of a standard SQL. Now, in when we are dividing SQL, it can be broadly divided into three categories. But in some advanced analytics, we still have some other categories that we have. For instance, now we can do SQL in terms of data definition language. We can do it in terms of data control language, and there's also what we call data manipulation language. What's the difference? From the word data definition, we are defining the data. In terms of data control, we are controlling permission and access. When we're talking about control, we are controlling permission and access to the data. When you're talking of manipulation, manipulation is that we are talking about what? Transformation. We are manipulating existing data sets. In the data definition, data has not been available. We are just defining it. In terms of data control, we are controlling access. We are controlling access and permissions. And in terms of data manipulation, we are doing a kind of transformation on the existing data set. All right. So how do we go about it? Now, the idea is that for data definition, we have some commands. These are what we call commands. I think I mentioned something around command the other time. This is what we call commands. This is also command for data control, and this is a command for what? Data manipulation. But their usage are different. There's what we call SQL. There's what we call SQL commands, and there's what we call syntax. I think I've mentioned the two terms before. There's what we call command, and there's what we call syntax. For instance, now, if you are using a command that is create, like this illustration we have here, if you're having a command that is what? Create, there are some syntax that must follow. The first syntax for create is that, what are you trying to create? Can you see from this syntax? Create, this is what we are trying to create. We are trying to create a table. The next syntax is, what is the name of what we are trying to create? The name of what I'm trying to create is what? Is product. That's the syntax. That's the flow. That's the flow of that, how I can, make use of that command. Now I've said, okay, create what? Create a table. And what is the name of that table? The name of the table is what? Is product. Then I now do bracket open. Then I now want to provide information about what? About the attributes of that table. But the attributes, we mean what? We mean the column headers, the column header. In the syntax again, the first column header is known as what? Product ID. Now, what should now be the characteristics of that product ID? It must be an integer. That is data type. The data type is what? Is an integer. Okay, I also want to make it my what? My primary key. Can you remember? So it means that this table I'm trying to create is likely to share a relationship with some other tables. I use comma just to end that definition of what? Of an attribute. I go to the next one. Another column header. Call it what? Name. Then make it what? In terms of data type, make it Vasha. By Vasha, that is, it can be combination of what? Text and what? And numerals. Yeah, I'm now giving a constraint that the total length of that variable, the total length of that variable should not be less than what? 20 in character, including spaces. For instance, now, if I'm defining a product name that has character greater than 20. It will not contain, it will not be, that product name will not accept it, because I have defined it to be what? To be of 20, to be of what? To be of 20, to be of 20 character in term of text. To be of 20 character in term of text. All right, so let us I'm thinking I should round up in the next by like 8 minutes more. I'm thinking I should round up in 8 minutes more, so that we can continue from there. Wherever we stop, we'll continue from there. Let me look at my time. Oh, I have 9 minutes more. I have 9 minutes more. Right. So that is about that. Then I now say, okay, let there be under the create, let there be another what? Let there be another column, which name is what? Price. And what is the data type? Can you see the syntax? Immediately you declare a variable, you are writing under the create. Immediately you declare a variable, then you are writing the what? Immediately you are writing the what? Data type. Then from the name here, can you see after this, we also have what? Not null. The idea about not null is that column can never be empty at any point in time, which is correct. Why will it not be empty is because we're having a product table. Is it possible we have a product that does not have a name? The answer is no. Any product that has been defined must have a what? A name. And that's why that clause is what? Not null. That is, you cannot have a product name that its name is empty. If you now go to the price, we have declared a table, we have declared a column to be price. We have declared the column, we have declared the data type to be decimal, and we said none. The answer about none is that, of course, you can have a product that has a name, but its price is none. That is, the price is empty. What can cause a price to be empty? Maybe when we are out of stock. If we are in stock, if you have a product in stock, of course, the price tag will be known. But immediately we are out of stock, because we are not sure of the next available price for that product, so the price will also be known. And that's why we are also attaching this non possibility to that price. So that is about issue about SQL. It's about SQL is where I'm so versatile with it. And it's a session that I take for 5 days. Yes, I take it for 5 days. If I have to teach anybody on SQL, it is a class of 5 days, because we have to look at so many areas about SQL. And mind you, I've mentioned SQL as the foundation that is a unified factor to all data professionals. How many minutes more do I have? I have 6 minutes more. All right, let us look at this. Other common database objects. Now, table is one of the objects that we have in our database. Other data objects that we have, we are looking at data objects. We have views, we have stored procedures, we have indexes. Now, what are the difference between them? By the time we are talking about views, view is that when we have created, we have worked on one command, that is creating a table. By the time you created a table, you have the data entries, and you now do what? You now query that table. You query that table, that you want to see some content from that table. I can say, okay, select this. I can say select. Select is another what? Select is another command, which is under data manipulation. I can say select. Select what? Select 2 columns. From the product table, select product name, which is name. Select product name, which is a name, and product price, which is price. All right. Another syntax that follows select is what? From where are you that from means where are you selecting from? I'm selecting from what? A product. I'm selecting from what? From a table, which is what? Which is product. I'm selecting from a table, which is a product. Immediately I click enter. Select this from this, and from what? Immediately I select enter, right? It will give me a view. It will give me a table. I've issued a query now. It will give me a table. That table that shows is being referred to as what? As view. Is being referred to as view. And that view is what we call a temporary or a virtual table, because it is only table that you have defined that is permanent. Anyone that you generated as a result of running a query is just temporary, is just visual. And that's why it is being referred to as what? As view. So that is that about view. About store procedure. Store procedure has to do with, okay, I want to run some what we call manipulations. I want to do some kind of data manipulations, and or I want to do some kind of data transformations. In this case, maybe what I want to do from this illustration that we have is that there's a product that has been renamed. There's a product that has been named. For instance, now, the kind of changes I want to do is that wherever you see a product ID, do you see that? Wherever you see a product ID under a product table, replace whatever name you see there with what? With spanner. I may not be bothered about the name that is there. I can write a syntax that, okay, go and look for a what? Go and look for a product table and look for an ID under that product table. Whatever name that you see there, just replace it with a new name. It was formerly Reg. I want to call it what? Spanner this time around. Now, what we invoke is what we call stop procedure. And in stop procedure, the idea is that, for instance, if you have a data set that is 10,000, yes, you have a data set that is what? Of 10,000 cases or 10,000 rows. And maybe you have places of 200 where reg appears. We have 200 cases where reg appear. Is it possible that you go and be looking for reg one after the other and change it to spanner one after the other? Technically, it is not possible. So the thing that you can do, you can invoke stop procedure by defining a kind of parameter. And that parameter is that, okay, I want to update my product, that is update my product table, whereby I have a new name for a product where a particular product ID appears. Now I can say, okay, in the end of my syntax, I can now say, okay, let us execute that rename product where I have what? Can use another create now. I want to create. The other time we created what? Table. This time we are creating a procedure, a stop procedure. I want to name it as what? Rename product. So generate a rename product wherever you see an ID under product name that is so on, they'll call it what? Call it spanner. That's an application of what? Stop procedure. In terms of index, this is where I will stop for today. In terms of index, we are making use of index to improve our what? To improve query performance. For instance, now, index. What does index does? If you have looked for index of a book, the index of a book can be maybe chapter 1, chapter 2, chapter 3, chapter 4, chapter 5. If I'm looking for any particular story, I would rather go to the chapter that has discussed it rather than looking for all the chapters in finding that information. You know, what does that index does for me? It has helped me to save time, because when I'm looking for a particular information, I'm also doing what? I'm also doing query. I'm looking for a particular information in a chapter, but I would rather go to that chapter that has defined that thing rather than checking it from the beginning to the end. So now, anytime you are talking about improving query performance, that is the speed of getting the feedback on what you are requesting for, that is what the essence of index is. And in this illustration, there are two indexes that has been provided, and this index is in terms of, okay, we are looking for a product, under a product whose name starts from this alphabet, A to L. We are assigning a different ID to it. And this, we have categorized alphabet into two. That is, we have A to L that starts, which product name starts from A to L, or it starts from M to Z. This one is group 1, and this one's what is group 2. So wherever you see AMA, you can say AMA, which letter H is between this, and that's why it's having 1. We're having 1, 2, 3. Then for that's why it is belonging to this category. And wherever we are having S, we have screwdriver, we have spanner. You can see that S falls within this side. And that's why our value, we remember key and value the other time. Our value here is now what? 162 for screwdriver and because there are possibilities of having different types of screwdrivers. But it is the ID that will give us, okay, 162 for screwdriver, that its price tag is 3.49. Then I can also have 164 for spanner, for screwdriver again, screwdriver whose price is maybe $4 USD. So it depends on that. So this is how far that will be going. For knowledge check, can we quickly do this knowledge check? Can we try knowledge check? Just provide answer. For A, what is the answer for A? What is the answer for B? What is what is the answer for 1? What is the answer for 2? And what is the answer for 3? Just a minute, just to ramp up this section. Is anybody responding? Suraj, somebody is asking for attendance as an attendance link. Okay, I have Jabo. He said question 1 is A. I have Michael. He said question 1 is B. I have Kathy. Question 1. He said question 1 is A. I have Timothy again. Very sharp guy. He has provided answer for all. Okay, let us sit together. Okay, let us sit together. Let us sit together because time has gone. So for question 1, the answer is A. For question 2, the answer is C. And for question 3, the answer is C. This is how far we have been able to go on this particular course. Please mind you, this is supposed to be DP 900 is 8 hours class, but we are just trying to see how we can save time so that we can have quality training and we can have quality knowledge absorptions. I'm not used to rushing people when I'm taking training. I make sure whatever I deliver, people can relate with it and they can digest it for further processing at their end. So I want to thank you for giving me this privilege. I look up to part 2 of these sections where we'll be looking at non-relational database and what? Data analytics. Today we have covered the areas of core fundamental of data, core data fundamentals. We have also looked at what? We have also looked at what? Relational database. The other side of relational database that we have not covered is the issue of Azure services for relational database. We'll take it up from next class. Thank you so much. Suraj, I'm done.
Thank you, Apula, for the session, and it was really resourceful. Since I was going through it as well, and I
Yeah, thank
hope
you.
it was useful for the attendees as well, since there was knowledge check on every module, so it was relatable
Yes,
since we
yes,
had
yes.
that. Yeah. So I think we are on time. I think 2 minutes, but it's it was useful for you everybody, and thank you all for joining with us and spending the 2 hours to hope it was useful for the spending of the time, and you had learned something new, and you can take away the knowledge. So
Yeah.
that's it, and thank you for the session again, Kapula, and for being a really useful trainer. I would say it was a really understandable session. So yeah, I'm hoping we'll have a follow-up session with him, and another we can follow up on it. So yeah, that's it from my
Yeah,
side, and
it's
mhm.
my pleasure. It is my pleasure. It is my pleasure.
Yes, great.
Yeah.
That's it from my side, and there is no more questions in the chat box as well. Since that's the case, we can wind up today's session, right?
Okay, that's fine. Thank you. So once again, I want to thank you all for finding the time to to stay behind the schedule time. Sometimes you have a lot to say, but time may not be of advantage to you. But I also want to thank you for having time for the extra time that we have spent. I think it is a worthwhile. I think it is a worthwhile. Thank you once
Yes,
again,
definitely.
and see you next time.
See you. Thank you.
Yeah, bye bye. Yeah, bye bye. Thank you.